Hello! Today I'm going to talk about dilations and scale factors. Let's take a look at the word dilation, what that means. It actually means to enlarge something. Dilation is to enlarge. To make something bigger. If your eye is dilated, if the iris of your eye, pupil, excuse me, if your pupil is dilated, it means the pupil of your eye has gotten really big. If you ever look in a mirror and go like this, you can watch your pupil dilate. It gets bigger or it gets smaller. In darkness, your pupil dilates, it gets really big. The opposite of dilation would be a contraction. Which means to get smaller or reduce. So we have a dilation, which is getting bigger. So what I'm going to do, I have this image here. Kind of looks like an upside down, kind of a diamond-y thing. And the instructions are telling me that I need to graph this image after a dilation with a scale factor of 3. And it's centered at 0, 0. What I'm going to do is I'm going to make this thing 3 times bigger. So here's how I'm going to do it. This point currently is at 3. Well, multiply that by 3 for 3 times bigger. That's going to take it up to a 3 times a 9. So here's the point over there. This is currently at a 2. Well, what's 2 times 3? I'm making it 3 times bigger. It goes out here to 6. So that 1, negative 1 times 3 is negative 3. Negative 2 goes to a negative 6. And here's my new image. So each side is actually grown by 3, a factor of 3. So if this side was originally 5, now it's 15 or something like that. So everything grows by a factor of 3. That's why we have the scale factor of 3, a scale factor of 3. Let's do another one of these. This guy's actually really basic. Write the coordinates of the vertices after a dilation with a scale factor of 2 centered at the origin. All I'm doing is I'm taking each point and I'm multiplying it by 2. So I have this point right here. Zoom in on this guy. And each x and each y is going to get multiplied by a scale factor of 2. So negative 4 times 2, that's negative 8. Negative 5 times 2, that's negative 10. All I'm doing is multiply points by 2. That's all I'm doing. Multiply points by 2. 2 times 2 is 4. Negative 5 times 10 is negative 10. 5 times 2 is 10. Negative times 2 times 2 is negative 4. Negative 1 times 2 is negative, by 2 is negative 2. Negative 4. So all I'm doing is I'm taking the x value, multiply it by 2, y value, multiply it by 2. Is that right? Looks good. Let's go on to our next one. So I'm going to graph this image after a dilation of a scale factor of 2. So let's think about this point right here. This is at 4, 3. And I'm using a scale factor of 2, so that's going to become 8, 6. 8, 6. This is at 4, negative 3. Scale factor of 2, that takes it to 8, negative 6. 8, negative 6. This is at negative 5, 3. That's going to take it to negative 10, 6. Negative 10, 6. This is at negative 5, negative 3. That's going to take it to negative 10, negative 6, negative 10, negative 6. There it is. Here's my new rectangle after a dilation of 2, which means I made each dimension 2 times bigger. The question on this one says the purple shape is a dilation of the black shape. What is the scale factor of the dilation? So instead of purple, let's say this is red. So what happened to this guy? Here's this little triangle, and it got bigger. Well, how much bigger did it get? Basically, I have to just look at a point. Let's look at this point. That is at negative 3, 3, and that point got bigger to this guy right here, which is at negative 9, 9. Well, what kind of scaling happened here? A 3 to a 9? Did it double? Which would be a scale factor of 2. Did it triple? It tripled! It tripled! That's a scale factor of 3. The scale factor there we go. And that's it. How long did that take? Less than 7 minutes. Brilliance here in 7 minutes or less. Go do the work.